Hi there, I'm David Sellers with Facility Dynamics Engineering. Some of you may be familiar with me from other training videos or for taking classes. This particular video is a system diagram exercise. There'll be two. This one sets the exercise up, sort of gets you familiar with the models that you'll use and some of the techniques and a little overview of them. And then the second one will provide the answer. The idea is that you'd download the models and the videos, watch this video, then work with the model to develop a system diagram. And then once you thought you had it, or were starting to make yourself crazy because it was frustrating you, you'd watch the answer video, and basically I'll walk you through how I did it, show you the answer I came up with, and then move on and explain why it matters, and use the system diagram to talk a little bit about how the plant and the model works. It's a variable flow primary secondary plant. I'm just going to give you a few quick overview things that will maybe help you with that. Like I said, if you're taking this in a class, using this in a class, your instructors, and if it's me, it could be me, may have already told you these things, but just to get everybody up to speed. So a couple things. System diagrams in general, there's not really a good resource out there. There's not a book. And so when I did the class the first time down at the Energy Center, I actually wrote a string of blog posts, and they're pretty easy to find. If you just go to Google and you type in David, oops, get your hands on the right keys, David Sellers Engineering blog, you'll actually find my website pretty easy. So there it is. This is the blog. There's a blog and there's a website. You can get to the website off of this link right here. But once you get to the blog, there's actually a system diagram category. And so if you want to find all the blog posts on system diagrams, just pick that category. And basically any blog post on system diagrams will be brought up on the screen. And if you navigate down to the bottom, you'll find the first post in the series, which is the starting point, and this post right here. So that's how you can get some resources just to help you to learn how to do the concept. If you're looking for the actual models and stuff that are behind these videos, and you're not taking a class, or your instructor's just pointed you at my website, if you go to my website, you'll discover that if you go to resources, there's a page with the Sketchup model links on it. And the idea is you'd use this page, you'd pick the exercise you're going to do, for instance, a system diagram exercise. There's also information on how to get yourself a free copy of Sketchup. It's called Sketchup Make, and install it, and links with some general resources about how to use Sketchup. So one way or the other, this hopefully will get you set up to use this resource if your instructors haven't already done that. I guess just to move forward a little bit with the exercise itself. The exercise basically takes place in a central chilled water plant. And the idea is to give you a virtual experience with trying to walk into a mechanical room and trace out the piping for a particular system. So this mechanical room, as you look at this image of it, it looks fairly complex, and a real mechanical room is even more complex than this. There'll be things in the way of what you're trying to see, and truth is, in SketchUp, you have the benefit of being able to move around, and without having to go find a ladder and climb it. You can do things like turn off the ceiling, which you can't do that in a real building, but it does make it easier. So for instance, and I guess I should point out here, these little numbers you see across here, they're tabs that have preset scenes in them. In other words, you could just zoom in and out, and orbit and pan the model, and again, the instructions on how to do that are at some of the links in the general resources I mentioned earlier. You could even go in here and go to the layer, if you want to lock that on, incidentally, you click on the little thumbtack and that'll actually lock those menus on there. And so you can use, the layer manager here to turn layers on and off if you wanted to. But you can see there's a lot of layers. That's how I manage some of the content, and I'm able to do some of the things I do with it. And so that could be pretty overwhelming. And so to make that easier, I've created these scenes. And the reason they're numbered instead of, with text to identify them, there's two reasons for that. One is there's a lot of scenes, and if I number them, these tabs are relatively small, and you'll see more of them on a given monitor without having to pan and scroll. The other is if I name them, it will give away the answer to some of the things that I'm trying to do with exercises in the model. There's actually a scene tab key that we could provide. I'm not going to do it now because it would give away some of the answers in here. But the point is, using the tabs make it easier to move around in the model and get you in a general location, and then you can zoom and span. So I'm going to unclick that thumbtack, and basically, if you just start clicking on these scenes, you'll discover they take you to various locations in the model, which could be useful for you as you're exploring it. So for instance, this got you right up to that first chiller, and so you can now, I'm rolling the zoom button, you can now zoom in and out, you can orbit, you can pan, and you can look at the piping in different ways. And so to get started, one of the guys I work with, Sebastian St. John, said the first time he did this, it was overwhelming. Like, he walked into a real mechanical room and it's like, oh my gosh, there's all this big machinery, there's all these pipes every place, there's lights, there's hangers. How do I start? This is overwhelming. And I had that same experience. I think just about anybody who does this has that same experience. And so you've walked into a mechanical room, you're at the door, and you're seeing something like this. And so what do you do? How do you get started? And the trick for me is just to find a spot you can identify and come back to that is related to the system you're trying to trace out. Put your hand on it, put your pencil down on your paper, and draw a line. So for instance, our assignment here is to try to trace out the chilled water system. And so, if you look at this model a little bit, you'll finally realize that the piping that's color coded, sort of the light blue and the teal color, that's the chilled water piping. The condenser water lines are green. These are domestic water lines that we aren't even going to worry about in this particular exercise. These are heating hot water system lines that run through the mechanical room. Again, we aren't even going to worry about those in this exercise. And so the pipes that have these colors on them, this color on the insulation, that's the chilled water system. Now, I've actually turned the insulation off on a lot of the piping so you can see the details behind it. And like on a real chilled water system, these valves would be insulated over, because otherwise when the system's running you get condensation and there'd be water dripping all over the place and they'd get rusty and stuff like that. But I did keep the insulation turned on where the pipe hanger's on, so you can sort of use that as a guide. And so what I'm suggesting you do to start is just like I might have picked these service valves where the lines come in the mechanical room. There's a set of service valves. Pick a service valve and just start following that pipe and draw what you see as you follow it. We're coming along here, the pipe offsets a little bit. In a system diagram, you aren't so worried about the elbows. The elbows aren't very important in a system diagram other than to organize it. They're very important in a pump head calculation, but not that important when you're doing a system diagram. So, if I was doing this so far, where I'm running my little cursor along, that would have just been a straight line. And it would continue to be a straight line until I got to here. Now I got a T. So I have to, my straight line becomes two straight lines. And I follow one branch or the other. And, you'll make sketches and there'll be multiple sketches and you'll reorganize it. You aren't going to draw a perfect system diagram right off the bat. If you look at my work, like in the example I give, in the blog post about how to develop a system diagram, and there we're using the Pacific Energy Center's ice storage system. I show you, like when I first did it, I had 20 pieces of paper with little squares saying this connects to point A on the second page and stuff like that. that's how this stuff starts out. Eventually, as you explore it, stuff starts to become clear, things start to untangle in your head, and you'll get an organized diagram out of it that it has some of the features that we talked about, that I talk about in the blog post on system diagrams. It's untangled, it looks like a ladder on its side, things like that. One thing that really does matter is the order of connection. In other words, you come off of this T and you discover there's a T for 2 pumps. Well, you literally have to draw your system diagram so that if you were tracing it with your finger, you'd come to this T that goes to this pump, which I believe is chilled water pump 2. You'd want to make sure that when you were tracing this pipe out on your system diagram, once you've drawn it, it would be just like the field. In other words, you'd have to go past the T to chilled water pump 2 to get to the T to chilled water pump run. Now, when you're drawing the system diagram, you can say, oh, I could untangle some stuff if I switch those 2 T's. That's the point where you don't want to untangle it anymore. That actually undoes a lot of the benefit of the system diagram. So the order of connection matters, and if you want to know a little bit more about that, there's actually one of the blog posts is order of connection matters. One thing I should mention to facilitate doing this, like most of us just start up with pencil and paper, but eventually the question of well, how do I draw this electronically these days? How can I do that? And a lot of people don't have access to things like AutoCAD and Sketchup is a really great medium for drawing 3-dimensional stuff, but it's not a very great medium for drawing 2-dimensional stuff and doing text. What I discovered is that a lot of people, more and more since Word and Office have been around, Microsoft Office Suite's been around, they're kind of comfortable drawing things with Microsoft drawing toolset. So I actually started drawing system diagrams for my classes in PowerPoint. And as a result, I now have a pretty good library of PowerPoint symbols. And the symbols you make in PowerPoint you can just as easily copy and paste into Excel or into Word. But the point is, if you go to my blog, what I just did was I went to Resources, Tools, and I picked System Diagram Symbols. There's a page there that talks a little bit about the symbol set, and then it links you up with my PowerPoint symbols library, some example system diagrams I did in PowerPoint, and it also actually links you up with my AutoCAD system diagram library for whatever it's worth, and a couple AutoCAD drawings that you might want to use if you happen to be doing this in AutoCAD. So I wanted to mention that as a resource. One other thing before I close this out and just let you have at it, this model here is the plant, but part of the system diagram is, and the system concept is, well, how does the plant interact with the loads? So it's important that your system diagram at least include, here's how a typical load's piped. And to help with that, we have a model of one of the typical loads. It's this air handling system. And so the second model you want to look at is as you're drawing your system diagram, you want to look at the model of the air handling system, find the chilled water lines. And again, there's some tabs, and these are labeled because I haven't used these in an exercise where I don't care about the answers. So these are labeled with text. So that zooms you in on the chilled water valve and chilled water pipes, and you can add this connection. Here's how a typical air handling unit is connected to this system. And I will tell you, this is typical of the way loads on this chilled water plant are connected. So if you understand how this load's connected, you basically understand how all the loads are connected on the plant. So having said that, I think I'll just close up and go ahead and let you start your system diagram process. Like I said, once you've done it for a while, think you have a good diagram, or if you're starting to feel frustrated, you don't want to frustrate yourself too much. A little bit might be good. That sort of inspires you. A lot of frustration, probably not good. Maybe that's the point when you just say, you know what, I'm going to open up that second video and see how David would have done this. And then the other thing you'll get out of that video is, here's how you can use this system diagram in a design methodology, or in a existing building operations methodology, or existing building commissioning methodology. Lots of ways to use the system diagram, and also we'll talk a little bit specifically about how this plant works. It's a variable flow primary secondary plant. And in doing that, you'll start to see some of the clues emerge about potential opportunities and issues that you've identified because you've drawn a system diagram. So, thanks for tuning in. I hope you enjoy this. I really enjoy making system diagrams. They're a really powerful tool. One of my favorite things to do when I'm out in the field and doing this. So, take care, and we'll see you in the second video once you've had a chance to develop your own system diagram. Thanks a lot.